Hello guys and welcome back to Mossy Maths with me, Tom Moss, and today we're going through the second lesson covering the topic of logarithms. In this lesson we'll look at extending our prior understanding by looking at the three main laws of logarithms, as well as how we can change the base, which is an important formula you need to learn for those of you with a graphical or scientific calculator that does not allow you to change the base, which will be most of you watching this video. So the first law, log x plus log y equals log of x times y. Now that's with base a, and notice the base is consistent with all the terms. The second law, log x subtract log y is log of x divided by y. Again, the base has to be the same value. And finally, log of x to the power k is equal to k multiplied by log x, again with base a. And these are all equivalences, we have equal signs, so we can use them in the inverse way. For example, this is equal to this as well as this is equal to this. We have 4 examples we're going to go through. Before I do that, I'm going to look at how we can change the base of a logarithm. So, if we have log of x with base a, then this is the same thing as log x with base b divided by log a with base b. Now, at first you might think, what on earth does this mean? And this is why I've got an example below to go through just to clarify. If we have log 4 with base 7 and we're told to find the value of that, then for those of you with a calculator that doesn't allow you to specify the base, you would type in something like log 4 divided by log 7, and that would be the same thing as this. Because, as I said in the previous video, the log function automatically has base 10 when we aren't allowed to specify the base. So this is the same thing as log of x, in this case the x is 4, with base b, now the base is always going to be 10, divided by log 7, which is the base for this, and that will have 10 as well as the base. So the value of b here will be 10. I'll write this in, although it's not necessary to do that, because you won't be allowed to type this in on your calculator. You'll just type log 4 divided by log 7, and that means the same thing as this. Again, you might need to go through this a few times just to make sure you completely understand what I mean by this. Put in some values, try it out, and see if it works. Now, we'll go through the 4 key examples I have here. I'll go through these 2, but with these 2 I'd like you to pause the video and have a go for yourselves. So to start with, write each expression in the form of log n with base a, where n is an integer. Now remember, integer just means a whole number. So the first example, log 5 plus log 4 with base a. The base is the same, so we can apply the first law of logarithms. This is log a of 5 times 4, which is log a 20. Okay? The second one, 2 log 6 with base a, subtract log 9 with base a. The base is the same here, although you'll notice a difference. We have a multiplier of 2 in the front of this logarithm, and therefore we can't simply apply the second law. We have to first apply the third law to get rid of this multiplier in the front. So all we do is we move the 2 up as a power of 6. We're reversing this. So the 2 is the k here, and we're moving it as the power of the x, which is 6 in this case. We then subtract log a of 9. Well, 6 squared is 36. And so we can now simply apply the second law as we would before. This is equal to 36 divided by 9 is 4, so it's log 4 with base a. Now for these 2, pause the video and have a go for yourselves, and then I'll go through this straight afterwards with you. Okay guys, hopefully you've paused the video and had a go at these questions. Log 20 with base a, subtract log 2 with base a, with a multiplier of 2 in front of it. We have 2 log 2 of base a. So again, similar to this example, we're going to have to move the 2 up as a power. So we have log 20 subtract log 4, which is equal to log of 20 divided by 4, applying this law, which is log 5, again with base a. So now let's move on to the last example. The last example states that a half log 16 with base a plus a third log 27 with base a. We need to simplify this. So what we need to do here is we need to apply the third law twice, and then we need to apply the first law. Although you will have need to have watched my first lesson on the laws of indices to know exactly how this will play out. For example, with this one, yes, we can move the half as a power of 16, and with this one we can move the third as a power of 27. Although, how do you do something to the power of a half? If you're not sure about this, do go back and watch my video on the laws of indices. The way we do this is the power of a half is just the same as a square root. So we have 16 to the power of a half is the square root of 16, which is 4, plus log of 27 to the third, that's the cube root of 27, which is 3. And now we can simply apply this first law of logarithms as we would before. 4 times 3 is 12, so we have log 12 with base a. And that covers the second lesson on the topic of logarithms. Hopefully that's relatively straightforward. In the next lesson we'll look at exponential graphs as well as log graphs, and then we'll be moving on to some exam style questions, which is perhaps the most important part of this topic. So thanks a lot for watching the video. If you have any questions, feel free to leave a comment and I'll try and get back to you with a response as quickly as I can. If you haven't, please leave a like on the video, and if you haven't already, please subscribe to my channel. Thanks a lot, and I'll see you in the third lesson on logarithms.